If you know we're like a new immigrant, you want to. All right. Okay, we're going to start our next unit here. But we're going to have to revisit some of the units from previous unit. So we have, so this is the rest of the semester. We have vectors and polar graphs coming up. Vectors this unit, polar graphs next unit. These two units, we're going to experience a little bit of trig. So we'll spend today reviewing right triangle trig. It's not going to be as intense as the trig that we experienced last semester, but we should need to review a little bit. I think most of you guys should find it pretty straightforward with the review. And then the rest of the semester, we have conics, stats, and logs. You've seen logs and exponential functions, but we're going to do a review of those topics in preparation for next year. Many of us are taking AP Calculus AB, so you'll need that. And then there's no final exam this spring semester even. Okay, so we're just going to do pages 1 and 2. Okay, so today we're going to do just right triangle trig review, and then we'll start with vectors. No quiz next week, but the following week we'll have vector quiz, vector operations, and then again it's going to be the word problems. It's going to take a little bit of time. The last thing that we do, and then tests on the 15th of February. Okay. All right, let's go to page 1. Sorry, page 2. All right, so we should feel very familiar with this, but we definitely want to have a good feel for all of this. A lot of what we're going to see in future units, we're going to rely on a right triangle trig. So Pythagorean theorem, we know that a squared plus b squared equals c squared allows us to find any missing length of a right triangle. Sine, cosine, tangent. So SOHCAHTOA, this allows us to find either missing side or missing angles of a right triangle. You're gonna need your calculator today. If you don't have it, you can kind of just follow along. Okay. So number 1, find the length of the hypotenuse and the measure of the angle of elevation for the given right triangle. So Pythagorean theorem will help us find that hypotenuse. So take the square root. Hypotenuse is 25. All right, if I want to find theta, I'm going to create an equation that relates the sides. So I'll just use the 7 and 24. If I want to use 7 and 24 and theta, which trig equation can I use? Tangent. Okay, so I can say tangent of theta equals opposite over adjacent. It says to solve for theta. To solve for theta, how do we get theta by itself? We make it what? Inverse, yeah, inverse tangent. And these will be in terms of degree, so make sure you're in degree mode. So inverse tangent of 7/24. Which is around to 2 decimal places. Okay, easy review, right? Okay, so go ahead and try 2 and 3. Let me know if you have any questions about your calculator or you need a review of how to enter the calculator.
Thank you. I can.
Okay, any questions 1 through 3? Okay, number 4 says find the lengths of 2 legs for the given right triangle. What we can do is we can just use trig to solve for one variable, and then just use Pythagorean theorem to find the third missing side. So you can do this a number of different ways. You don't have to do it the same way that I'm doing it. But I'm just always going to solve for x. That's the first variable that I see. So if I want to solve for x, I have to make sure that I cover up y. I don't want to involve y. I just want to solve for one variable at a time. So which trig equation? Cosine. Cosine will allow me to hit the theta, the adjacent, and the hypotenuse. So say we know cosine theta is equal to adjacent over hypotenuse. I'm just going to fill everything in and allow me to cross multiply and solve for x. Of course, you can rely on sine. If you want to solve for y, you're perfectly welcome to use that. Or you have all the sides available. You can use any of the trig function, or you can use tangent as well. Or you can use Pythagorean theorem. It's really up to you. Okay, go ahead and fill out 5 and 6. I'm skipping some steps here, but let me know if you want me to go over any one of these in detail. Yeah. Get this, yeah, this conversion button. Get it to this one. Wait, good.
Yeah.
Yeah, so you have to skip that conversion function. That's convert. Everybody okay? All right, number 9. Sketch each angle in standard position and then state the quadrant where each angle has its terminal side. So terminal side is where does that angle, as it swings, where does it end up? Which quadrant does it end up? So theta equals 140. Which quadrant is that? Less than 180, but greater than 90. So second quadrant. Okay, what about 285? Yep, fourth quadrant. All right, 11, terminal side of theta passes through -6, -5. So where's that order pair located? Third quadrant. Okay, try 12, 13, and 14. Okay, so negative 70 degrees, that means we're moving clockwise into the fourth quadrant, so 220. Counterclockwise, third quadrant, terminal side, negative 12, negative 16, we go left and up. That's in the second quadrant.
Well, I like added 360 to make it 290. Can we do that too?
It ends up being the same measure, but negative 70 is specifically going counterclockwise or clockwise. So we're gonna have to go in that direction. So if we go the other direction, yes, it ends up being I can add 360 to it, but if we follow that direction, it's going down. Okay, page 3. Okay, so sketch each angle described in the standard position for theta is between 0 and 360. Find the distance. The point is from the origin and the measure of the angle. So distance, think of distance as basically the hypotenuse of a right triangle. And the measure of an angle, like the previous page, we'll use either sine, cosine, or tangent. And inverse sine, cosine, or tangent to find the measure of that angle. Okay, but first, let's go ahead and plot the order pair, right? So 2, 9. Where's 2, 9 going to be located? First, second, third, or fourth quadrant? First, okay. So we know we're going to go to right and up. So it doesn't have to be to scale. So theta. Find the distance. The distance is just my hypotenuse. All right. It also says find the measure of the angle. So we have the distance, the measure of the angle. I'll rely on tangent. Make sure you're in degree mode. Inverse tangent of 9/2. Okay, number 16, terminal side passes through negative 8, 6. Which quadrant is that? Second. A squared plus b squared equals c squared. My hypotenuse is 10. Again, I'll involve a tangent. Now, we gotta be careful here because when we solve for theta, we want to find the measure of the angle, like as if we're counting going from 0. So when we find our theta, understand that it's just going to be a reference angle. We have to make sure we adjust it so that it lands as a second quadrant measure. But I'll call this theta prime for now. So tangent theta prime equals 6 over -8.
Why not data prime?
Because what we're going to find in the calculator is just going to be that theta inside the triangle, but it's asking for the measure of the angle, like as if it were being counted from from 0. So whatever your calculator is going to give you a theta value that is between 0 and 90, but it's not a true second quadrant value. We got to subtract from 180 for reference angles, right? So we know quadrant 2 measures have to be between 90 and 180, and we're going to make an adjustment when we get the information from the calculator. Okay, so let's plug this in. Inverse tangent of -6 over 8. Got to make an adjustment here. It's giving me -36.87 degrees, which we know that -36 is, that theta prime. We can think of it as a 36-degree measure, but if I want to figure out what is that quadrant 2 measure, right, we always subtract from what? Either 180 or 360, right? But second quadrant is coming from 180. So if I do 180 minus 36, it'll give me an exact degree measure that is in the correct quadrant.
Yes, I can.
Okay, go ahead. So if you're in the second, third, or fourth quadrant, the calculator will give you something that is related to a reference angle, and then you just have to make an adjustment to get it to a theta measure that's between 0 and 360 that's in the correct quadrant. Okay, number 17, -10, -10, which quadrant? So the calculator returns back to us 45 degrees, but I want 45 degrees in the third quadrant. So what do I do to get there? Plus 180. Yep, 180 plus 45 will get me to that third quadrant. Now, whenever we're dealing with these measures, we're only playing, or we're only starting from either 180 or 360, right? We never do reference angles from 90 or 270. Okay, we always are looking at those measures from the x-axis standpoint.
Was theta prime just referencing?
Yeah, theta prime is referencing. Right, right. Theta prime is a reference angle for the triangle, but it's not quite the theta measure that we want that lands in the particular quadrants. Okay, 13, -22, which quadrant? Yep.
So for C value, you don't have to put it in decimal form at all.
That's fine. Well, let's see. Doesn't specify, but I'm leaving it as exact value. Okay, reference angle is 59.42 degrees, but how do I get this into something that we recognize in the fourth quadrant? Subtract from 360, yeah.
Reference angle is a negative, you just take the.
Yeah, I just take the positive version of it, yeah. Okay, 19 through 22, same idea. It's just that we're going the other direction where instead of providing you the X and Y value, it's providing you the hypotenuse and the theta measure, and you're just working backwards using trig to help you solve for X and Y. Okay, sketch each point, describe with its given distance from the origin and angle measure. Determine the order pair coordinates as described. So the point lies 15 inches from the origin. So imagine this as the hypotenuse and a terminal side of 320 degrees. So which quadrant is this in here? Quadrant 4, okay? So we want to create a reference angle so we can have a triangle to work with. Always draw your triangle involving the x-axis as one of your sides. 15 inches from the origin, so it's always going to be your y value, sorry, your hypotenuse. So what's this theta measure going to be?
Sorry.
40, right? Because 360 minus 320, right? You want to get that reference angle here. I have that 40 degrees sitting there. Now we can have an easier time solving for X and Y, relying on either sine, cosine, or tangent. Okay, I'll target the X first. What can I do to solve for X? Cosine. I'm sorry, cosine of 40, right? We know the degree measure. Okay, to solve for y, you can either use Pythagorean theorem or you can use sine. But there's a slight adjustment here. I'm going to the right and I'm going down. So what's my order pair going to be? So 11.49 stays positive, but 9.64 needs to be what? Negative, right? So even though the calculator is returning back to you a positive value, you have to make the adjustment that if I'm in the fourth quadrant, I got to go right and down. So my order pair, my y value is going to produce a negative. Any questions with this process? work through 20 through 22 and go ahead and try those, and I'll go ahead and work it through on my own as well. It's 251. Order pairs in the third quadrant have to be both negative, so when you solve for x and y, you have to make an adjustment on your own and recognize that you're going left and down. So negative 9.44, negative 27.42. Quadrant 1 is the easiest because no need to find the reference angle. That theta measure is your reference angle, and all your order pairs are going to be at positive. Okay, so we'll pick up, this is good useful knowledge, but we'll start our first topic tomorrow, now that we have some trig review in our belt. All right, go and get your phones.